Hey there, welcome to dotnetFlix. Today our guest is Willem Meints, and he's going to talk about Azure OpenAI, right, Willem?
Yeah, absolutely. So today I'm going to take you along on a small tour along Azure OpenAI. For those that don't know what it is, it's an OpenAI implementation on Azure. OpenAI is the company that creates the models for Chat GPT. Large language models. They use it to generate a language. So most people will know it from generating poems, writing code. GitHub Copilot is based on the same types of models.
Yeah.
But today I'm going to show you the Azure version because I think it's very interesting for enterprises to use for internal chat applications or maybe generating content or categorizing text. It's useful for a lot of things. I personally created an application just like chat.openai.com, an internal chat version. And I intend to connect it to internal documentation from our guidance framework that we have at InfoSupport.
Okay. Cool.
I don't have that today. It's not finished by any means.
Hurry up, man.
A couple of weeks figuring out how it works. And I had a few hiccups. For example, Microsoft decided to change the OpenAI service recently. They removed a couple of models that I was using for completions. They're no longer there, but yeah, I'm in the process of converting everything to chat. You won't see that in the final version. Yeah.
Yeah.
I've got a couple.
So these are the exact same models trained by OpenAI as OpenAI uses them, except they're hosted on Azure, right?
Yeah, they're the same thing. Yeah, 100%.
Okay.
Cool. Well, let's dive in, Willem.
The difference here is that it's not connected to the open version, so you can have your own personal data in there, and it will remain in the Azure region that you created the resource in.
Right. So they're not training on your data then.
No, they won't. So that's a good news, I think. Yeah. So what I will do is I will cover what OpenAI brings to the table, what it looks like in the Azure portal. But I'm going to show you how to set up. We're not actually creating a resource at this time. It takes a little bit of time to set it up, but I will guide you through the process of what it looks like if you want to do it on your own. And then we'll switch to Visual Studio Code, the tool that I have open here. And we'll take a look at integrating Azure OpenAI Service into ASP.NET Core and the single page application. I won't cover the single page application. It's based on React, and there would be a whole different topic. So I will skip over that. That's just regular old rendering HTML from the responses that are generated by the model.
Okay.
What I will do is I will show you how to use the API from your own application and how to set it up so that you can have a conversation with the bot. We'll cover what it looks like in a little bit. And then finally, I will show you a few tips and tricks that I learned from building a chat application using Azure OpenAI. And I guess if you have more questions for me, I'm happy to answer them and browse the code a little bit. But I guess this is quite a lot to cover, actually, in just a few minutes. Yeah. So let's take a look. So Azure OpenAI Service, you can deploy that on Azure through the portal. So you can create a new resource and you can search for OpenAI, and I will show you the OpenAI resource right on the left, on the top left, and you can select Create. In my case, so I've already created one resource, so I can create more. But if you create this for the first time, you're not actually allowed to create one. What you have to do is before you create a new resource from this type, you have to fill out a form for Microsoft, and you will have to explain to Microsoft what sort of use case you're going to implement using Azure OpenAI. The reason being is that Microsoft is very careful about what they allow onto the platform. So they don't want any applications involving racism or any dangerous stuff. Medical applications are off limits. They don't allow that. So high stakes stuff is really not possible at this point. And the way they do this is by asking you to fill out a form, and if they deem it okay, you will get an email back from them, and they will tell you, yes, you're allowed to create Azure OpenAI Service instance. And then what happens is this last dropdown will have a value for you. So if you try to create an Azure OpenAI resource and you don't have a value in this last dropdown, the pricing tier, you will have to fill out that form. And it will take, they say it will take up to 10 days before they get back to you. But in my experience, it's only 2 or 3 hours, depending on how complicated your use case is. So that's a good thing to know ahead of time. Once you have a resource, you can access it through the portal. And it has a special console where you can configure the Azure OpenAI service itself. It's part of the Cognitive Services suite at Microsoft. And they all have the same sort of user interface. It looks like this, what you see here on my screen. There's a welcome page. You can have a few demos, the pre-generated demos, so you can explore things a little bit. Or you can jump right in and start deploying a model. And this is done through the deployments page. There are a few options that you can choose from. So when you create a new deployment, you can choose a model. At this time, I have access to GPT 3.5 Turbo, which is the fast version of GPT 3.5, the one that's used by OpenAI on their chat website. There's a new version, GPT 4, that's not available on my subscription that I'm using currently, but that's coming soon to everyone. They are still testing it at Microsoft. OpenAI itself already published the GPT-4 for general use, so I expect it will be a couple of weeks.
You can apply for a spot on the waiting list to get into the preview of GPT-4 on Azure OpenAI. I think I applied like 2.5 months ago, and I'm still on the list, so it may take a while.
Yeah, it takes a while, and at this point, given that OpenAI has released GPT-4 for general use, I expect that the waiting list is of no use at this point. So yeah. I would recommend people, if you're starting out, just use the GPT 3.5 version. It's especially in the beginning, it's good enough for what you're trying to do.
And it's still faster than GPT-4, right?
Yeah. GPT-4 is a lot slower in generating a response. The other difference is that GPT 3.5 has a token limit of 4,096, which is roughly 16 full pages of text that you can send to the model and get a response on.
Oh, that's quite a lot.
GPT-4 has about the size of a good book, let's say Shakespeare.
Oh, wow.
Yeah, that's quite a lot bigger. You can do more, but it also is a lot slower. That's the main difference between the two.
Summarize this book for my report.
Yeah, for example, you could do that in GPT-4. In GPT-3, that's not possible. You would have to do some clever trick to make that work. But it's that's coming up. And the other option you have here is a text embedding model. It's what you can do is you can convert pieces of text into a vector representation for search or for recommendations. That's also possible with OpenAI. I'm not going to cover that today. Maybe I will write about it on my blog because it's an interesting, different application for the GPT type of model. So once you have a model deployed, you can use it from your application. What you need to do is you need to grab a key from the Azure portal. It is in the spot where you expect it to be under keys and endpoint. You will also need the endpoint itself. That's the URL. It's also listed here on the top. And it basically points you to the URL where you can send the request to for the application. And if you want, you can use a custom domain name. I never do that, but it's something that probably larger organizations might want to do. There's a button on top to configure that. Other than that, there's not a whole lot you can configure in Azure OpenAI. There's monitoring stuff, but I found that the monitoring stuff is mostly it takes this amount of time to generate a response, and that's all you're going to get from the diagnostics here. So it's pretty limited. So yeah, that's how to set things up. But then, yeah, how do I use it in my application? That's of course the main thing for developers. How do I build something like chat.openai.com? I can highly recommend building a single page application in combination with an API for this, because what you will find is that it's rather slow. in generating a response. And there's a trick inside Azure OpenAI that you can use to stream the response to the browser. But of course, if you're using server-rendered pages, that's not going to fly at all. So let's take a look. Let's dive into the API portion of the application. So what it is, I built an Azure connected application. So in my case, I added authentication to make sure that only info support employees can get access to it. But otherwise, it's a regular ASP.NET Core application. So you could disregard this whole top portion of the application dealing with tenant IDs and client IDs and all that stuff. This on the bottom is actually the most interesting stuff to take a look at first. What I've done, I've created 2 endpoints in my application. The first one is /API/chat. And basically what happens is you can send a request to this endpoint and it will give you a message back based on the input that you provided. And the input in this case is a chat request, and the chat request is the stuff that I type into my text box and the history of my conversation. So I don't keep any state on the server in this case. I'm just sending it whatever I have on screen. What I forgot is actually to show you the assistant itself. So this is what it looks like in my browser. I can check if it's live. And it should just give me a response. This is what happens in my application. So underneath the covers, when I send a message, I'm sending the text from this text area that I have here at the bottom. If I were to send a second message, how old is the universe, I would have another message in there. And basically what gets sent is, again, the text area, but also this message and this message at the top. And from that, I will get a response from the language model. It looks at every piece of text that I enter and will basically predict the next token in the reply back to me. That's what's happening underneath the cover. So it will feed test 1, 2, 3. Are you alive? It will send all those words separately to the model. Then it will send this text to the model. Then it will send this text to the model. And then it will stop and it will generate the first word in the response here. But then this word is also added to the model as input alongside all the text that I have over here. And then it will send and it will reply with the next word. So that's why it's really slow, because it has to re-enter all my text again and again and again and again until it is finished generating the response. The good thing is I don't have to deal with that as a developer. What I can do is I can, from this method on my API, I can call my custom language service class that I wrote and ask for a response. So what I can do is press Ctrl F12 and I will go into my application, in my language service implementation, and we can take a look at controlling the OpenAI service. So what I need to do is I will need to create a new OpenAI client. In my case, I stored it in a private variable. And I need to tell it about the endpoint that I just saw in the Azure portal. And what I need to do is I will need to give it an API key. Otherwise, it won't talk to me. This way, requests get routed to the right location, and I can talk to the model. So, having said that, I have a client. Now we need to take a look at the next step. How do I actually turn this prompt that I entered in the text area and the list of history into a conversation? And the way it works is, what I do is I will grab the history and translate it into chat messages. So basically what happens is the OpenAI client will accept a list of chat messages as input. And the way I feed it to the model is actually by looking at this code. So I create a request options object, and I can feed it with a couple of settings, and then I can add messages to it. So it has a messages property I can call add, and I can create a system prompt. I can give it sample messages, and then finally I can add my own messages that I sent earlier to the bot and the responses that I got from the bot. And then finally what I will do is add the final message. That's the user prompt that I entered in my text area. And then when I've done that, so this is a lot of text already that's going into the model, then I can say, dear model, client, get me a chat completion. And please use the deployment that I want to use. In this case, I'm using chat. That's my deployment name. And what will happen is it will take a while. So it will send all those tokens to the model, and it will get back a reply. And that is what I send back to the browser. So it's overall, it is a lot of text that I'm using here to control the model, but you could control it with just a few lines of code, actually. The reason that I add a lot more code is because without the extra stuff that I have in here, the model would not really understand me. It would just reply in a very, very generic way. In this case, what I can do is I can ask, for example, I can say, what's your name? I can ask it personal questions. And it will reply, hi, I'm Ricardo. But how does it know that it is named Ricardo? You can ask the same thing on chat.openai.com, and it would say something else. And this is where the system prompt comes into play. You don't see that here, but I told the bot a lot of information about how it should behave. And that's actually the first part that I have in my method. I'm adding a system prompt, and the system prompt contains instructions for the model how to behave. What does it look like? Well, I wrote a small text file to build the system prompt. And basically what it says here is, you are an AI assistant deployed by InfoSupport that helps people find information and write project proposals. You play the role of Ricardo. So that's how it knows that it is named Ricardo. And then finally, I will tell it, you're very friendly and helpful. I could do a trick here. I can say, you're formal and reserved. I can say, it's not friendly at all. It's a very reserved bot. So I can say, can you tell me a joke? Oh, it's still happy. See, now I'm asking it, you're not very serious, are you? Because it joked before. And now it says, as an AI assistant, I'm programmed to be professional and courteous at all times. And that's because I told it in the system prompt, you're reserved and you're very formal. And this is a sort of a style that I'm programming into the bot.
So we can create some really dystopian bots that always respond in rhyme and stuff, right?
Yeah, you can totally do that. Yeah, you can change this into an instruction saying you should always make it into a poem. You should always try to make a haiku out of it, something like that. Yeah, but remember, it's only a model. It's not really a chatbot. What I'm doing is actually concatenating a lot of text here. I'm concatenating a bunch of strings together, and those strings get fed into the model, and it will predict the next token based on the string that I entered into the model. In C#, this looks like chat messages. That's because they figured that that would be a great interface for the model. But underneath the covers, it's just a bunch of strings that go into the model, predicting the next most likely word. So that's important to keep in mind. So using the system prompt, I can give it instructions on how to behave. And from there, I can start to chat and talk to the bot. And there are a couple of other options that are important here, and that's those are the lines that I have at the top here. These control what the response looks like in terms of how much variation there is between different instances of the response that I get. So how does it work? Let me first talk about temperature in this case. That's the most important one, I think. So when I ask it about the age of the universe, it will respond with prompt A. Let's say a response A in this case. It will respond in a certain way. When I increase the temperature setting and I ask the exact same question again, I will get a different response. Temperature controls how creative, if you will, the model is. It's not really creative. It's just that it adds a random factor to the output token that it chooses from. Basically, what happens if I send a message to the model, it will try to predict the next token. The way it does that, it has a dictionary of possible tokens, a vocabulary, just like we humans have. And for each token, it will predict the probability that that's the most useful token to respond with. And what it does, it modifies the probability using the temperature setting. So it creates a sort of a random factor to it. It says, well, at this moment, I'm not going to be friendly. I'm going to say something else. That's basically what happens. And then there's the other two settings at the top here. This controls repetitiveness. So if you set these settings, presence penalty and frequency penalty, to a low value, let's say 0 or -1, it will repeat itself over and over and over again. There's a high risk that that will happen. That's how you initially knew in the past that the model was generating text and it was not a human generating text, because the AI model would repeat itself from time to time. But nowadays, using these two settings, you can say, if you predicted the word "the" and the presence penalty is high, then the next word is very unlikely to be "the" again. That's basically what happens with these penalties. So that's how you control sort of the style of your bot, if you will. And then there's the final three settings. So max tokens controls how long is the answer going to be, the maximum of the answer. 800 tokens is quite long, as you can imagine. And then there's the option choices per prompt. So what I can do is I can set this to 3 or 4, and it will generate 3 or 4 alternatives per prompt that I enter. And I can choose from those alternatives. So I can give the user options, basically. What sort of response would you like? And then the final setting is controlling. So I mentioned the vocabulary. There's basically a large dictionary of words that it can predict. And I can say to the model, please only use the top 95% of the dictionary. And that means that if I have a possible 6,000 different words that it can predict, it will only take the top 95% highest scoring words for a given position in the text. So these options all control how the model is going to reply. There's no real good way to figure out what the best option is. My suggestion here is try a bit of A/B testing and make sure that you log everything during a testing period, because it varies. It interacts with the system prompt, it interacts with samples that you might have added to the bot. So yeah, it's black voodoo again in machine learning land, so to say. So yeah, that's actually the basics of Azure OpenAI and how to use it in your application. I already mentioned that A/B testing is a good idea in this case. The other thing that I can highly recommend is looking at few-shot learning. And that's a technique where I provide my model with a few more samples before answering the real question from the user. And why is that useful? Well, if you don't do it, you can get any answer. Basically, there's no control over what the bot is doing. But if I, for example, don't want the bot to talk about a certain programming language in a favorable way, I can give it a few samples and basically tell it not to talk about PHP, for example. As an example, that's what I've done. What I've done is I've actually said to the bot in the background, you don't see this in the user interface. Can you write me some code in PHP? Absolutely not. I'm not going to do it. And it makes it more likely that the bot is going to steer clear of using PHP in your code base. It increases the odds that it steers clear of PHP. We just tried it before the recording, and it didn't really work. But it's kind of politically correct in the sense. So we could try. Can you help me set up a project in PHP? Of course. Oh, okay. It does. Oh, I thought you didn't like PHP. So yeah, an AI assistant doesn't have any feelings. But yeah, it will help me either way. So you can see that it's sort of not doing its thing. But you can.
Is that also the difference, Willem, in asking it a specific question because you really asked it like, I want to do something in PHP versus, hey, just give me like a hello world code sample, and and then the bot probably wouldn't respond with PHP, hopefully.
A sample code for creating a web application. I have no idea what it's going to do actually in this case. This could take a while, depending on the size of the response. Yeah, of course it gets slower.
PHP.
It's going to be with PHP. That's super cool.
Of all the programming languages.
Yeah, I didn't expect this to happen in the sense that I was very clear. I don't want it.
There is an inversion somewhere. Somewhere there's an inversion, I think.
Well, I guess, Willem, what would happen if you change the system context or the system prompt to never show a PHP code sample?
We could do that. We can certainly try. Never show code samples in PHP. All in capitals, extra important. Let's put it that way.
Not that we don't like PHP, right? But we need to have an example.
Super curious what will happen in this case. It's kind of cool to try this out, and that's what happens in large language models. It's all probability based, so you can't really say ahead of time what's going to happen. In this case, it will still recommend PHP, but it will be more general because it's not allowed to show code samples anymore.
Yeah,
that's the thing. So. And temperature and frequency penalty and all the other settings have a role to play in here as well. So that would be my tip. Just make sure that you test it with a large amount of text before publishing it on the internet or in your organization, because you never know what's going to show up. That's the problem. It's not published either. So the thing with these large language models is, for most machine learning models, we know that there's a scientific paper that explains how it works in detail. For Chat GPT and GPT-4, there are papers that explain what the general idea is behind those models, but not in detail. And that's on purpose for safety reasons, they say. I think there's also competition that would be helped greatly if they knew how this model was made. But because of the fact that we don't know how it works in detail, it's all sort of educated guessing what we're doing. That makes it special in this case. So yeah, that's how what I have to show you about Azure OpenAI. Yeah, there's lots more to talk about, but I guess I don't want to make this a very long video in that sense.
Yeah, I guess you can make a video of about a week, I think, with all these topics, because it's very interesting. Yeah, we could make a series, but I think it's a good sample to show people what you can do with this with a couple of lines of code. And yeah, I always think that the unpredictability of these models can be fun, right? Because now we're just experimenting. But what happens when you really need a model that need to help people and stuff like that? So the testing and making sure that it reacts the way you want it to. There's a lot of tweaking going on, I think. So
And then what's the functional use case where you're going to apply it, right? What's the user going to expect? If the bot gives a strange answer, does the user think it's an okay answer? Will it just believe the bot? Or does it know it is talking to a bot? And does it know that it's basically all statistics? Yeah, that's really something hard to think about. But on the other end, the technical details, as you showed them, Willem, really easy. Like a couple lines of code, just set up those parameters and you're off to go. So that was, really impressed with that.
Absolutely. I think I spend about 80% of my time fiddling with the system prompt, fiddling with the samples, trying things out. And the rest is C#. Yeah, that's something that we I think most of our viewers will do on a daily basis. So yeah, this should be doable in that sense.
Yeah.
Cool. Okay, well, thanks for showing us this, and I hope you inspired people at home to start working with these kinds of tools and these kinds of services. If you like dotnetFlix, please subscribe to our channel, and we hope to see you at the next episode. Have a great one. Bye-bye.